So in this video, we're going to talk about absolute value. So absolute value has to do with how far it's away from 0 on a number line. So here's 0, and let's say you're at 5. That would be 5 units away. 1, 2, 3, 4, 5. Yeah, 5 units away from 0. But if you were at -5, that's also 5 units. I think that's 5 units away from 0. Okay? So the absolute value of 5 is 5, but the absolute value of -5 is also 5. So we're talking distance. It's not talking direction. So think about, if you were on campus and you lived 5 miles to the east, and then your friend lived 5 miles to the west, you're both still 5 miles away from campus, just in different directions. There is a technical definition, though, for absolute value. And it says absolute value is defined as it's x if x is greater than or equal to 0. So if you're taking the absolute value of a positive number, or 0, it's just going to be that number. But it's the opposite of the number if x is less than 0. Okay, so if it's -5, then you have to do the opposite of -5. And the opposite of -5 is 5. So sometimes people, when they're working over here, they're just thinking, oh, it just makes things positive. But the definition helps us with other things. Okay, like what we're going to do right now. So remember this definition. There, I'll try to keep them both on. It says rewrite each expression without absolute value bars. So what you have to do is you have to rewrite this. Well, you have to know which case it is. Is it the case where we just keep it the same, or do we take the opposite of it? Okay, so that's the choice. Well, how are you going to know? You're going to have to think about the numbers. What's the square root of 3? I don't know, but it's bigger than 1. Now, I can find out on a calculator. I can get a decimal approximation. Let's see, square root 3. It's about 1.7. So this is about 1.7. Well, that's more than 1. So if I'm subtracting them, then this is going to be a positive value. Therefore, I keep it the same. There, I've taken care of the absolute value, and I know whatever the value is the square root of 3 minus 1. Now, you might be saying, well, why don't you get a decimal approximation? If they don't tell me to, I'm not going to do that. This is considered an exact answer. Okay, now over here we have 2 minus pi. Well, pi is about 3.14, right? So here I'm getting a negative, right? 2 minus 3.14, that'd be a negative number. So I'm going to have to take the opposite of 2 minus pi. When I do that, it's going to make -2 plus pi through distributing. But usually we are going to rewrite that so that it says pi minus 2. Notice when we take the opposite of the original, that's switching places, right? Like now it's not 2 minus pi, but pi minus 2. Okay. Now let's look at this example at the end. We've got the absolute value of x, and it says x is less than 0. Well, if it's less than 0, that means it's negative, so it means we can replace this. The absolute value of x is equal to the opposite of x. Well, when I do that, then I'm going to have -x over x, and that just equals -1. Okay, so a little bit of thinking there about absolute value and what it means. Now there's properties, I don't remember how many there are, quite a few, for absolute value. And some of them are just going to maybe naturally make sense, but if you have the absolute value of a, that has to be greater than or equal to 0, right? We kind of said it's a positive maker, but it could equal 0 as well. If you have a number, that has to be less than or equal to the absolute value of it, right? So if it's a negative number, it's going to be less than a positive, right? The absolute value of the number. And if it's positive, then it's going to be equal to it, right? All right. So just a little bit of thinking here. Oh, I left one out. The absolute value of -a is equal to the absolute value of a. So now when you think about that, an example, the absolute value of -5 is equal to the absolute value of just 5, right? Okay, so if a is 5, and then you take the opposite of it, -5, those two values are equal. Okay. The absolute value of a product is equal to just if you were to split them up. So that one's exciting. And then in division, we have something similar. If it's the absolute value of A divided by B, that's equal to the absolute value of A divided by the absolute value of B. But we do want to make sure we know that B does not equal 0, since we're not going to divide by 0 here. Okay, and then the last property is the one that is probably the most exciting. I feel like I left a property out. There's 6 of them. 1, 2, 3, 4, 5. Okay, yeah, this is the last one. It's called the triangular inequality. And it says, if you have the absolute value of A plus B, that has to be less than or equal to the absolute value of A plus the absolute value of B. Okay? So you could think about them being positive numbers, or think about them being negative numbers, or one positive and one negative. If one's positive and one's negative, you'd take a difference. But that's going to be less than the absolute values of each one of them added together. Okay. Absolute value.